prefix for 5 is pent. So that's going to be pent. And then we know we have an aldehyde right here, the double bond of oxygen, a single bond of hydrogen. So we're just going to add our suffix -anol, and we're going to get pentanol. So let's move on to our next functional group. The next one is a ketone. A ketone is when a carbon in the middle of the alkane chain has a double bond of oxygen to it up top. So the way you write the suffix for this is -ONE. So let's see this in action. If you look over here, we have 1, 2, 3 carbons. So we know our prefix is going to be propane. And we know this is a ketone because it has a double bond of oxygen in the middle. So that's going to be, at our suffix on, it's going to be propanol. Let's move on to our next one, carboxylic acid. So a carboxylic acid functional group is when there is a carboxy group on the end of a carbon chain. So basically, it's going to look like it has a double bond of oxygen up top, and then it's going to have an alcohol group to the right of that carbon. The way you write the prefix for this is oic acid. So let's write this compound as a carboxylic acid. So first, let's count the carbons. 1, 2, 3, 4. So we know our prefix is going to be butyl or butane. So let's write butane. And let's add our suffix because we have the double bond of oxygen and the alcohol. Butanoic acid. And that's our answer. Our next functional group is going to be called an ester. So an ester functional group happens when there is an ether group, but on one of the carbons connected to the oxygen, is going to have a double bond of oxygen up above. So the way you will write this is you will write the alkyl group, and then you're going to write the alkyl group with the ester connected to it, or the one with the actual double bond of oxygen above, and it's going to have note. So that one was probably pretty hard to understand. I know I didn't explain it the best myself, but let's see what we're working on, right? So first, let's count the carbons. 1, 2, 3. And then we have 1. So you know that there are 3 carbons on the carbon chain with the ester connected to it because it has a double bond of oxygen, and then oxygen connecting the other carbon chain. And then on this carbon chain, it's just a methyl because it has 1, and then it's connected to the oxygen. Now, we write it as alkyl, and then the alkyl know it, or the ester know it. So the alkyl is going to be the one that doesn't have the double bond of oxygen. So since this is a methyl group, we're going to write this first as methyl. And now we're going to count the carbons on the ester group, which is 1, 2, 3. So that's propane. So it's going to be methyl propanoic.